Okay, so then I made this polynomial, okay, and I deliberately. So what I did, I'll show you what I deliberately did. So I'm having it. I had Symbol Lab expand this polynomial. That quadratic expression has two not imaginary but non-rational, irrational solutions, and then you see where there's two real solutions. One of them's got multiplicity 2. So pretend, you got to pretend you didn't see that. You got to pretend you said, this is what I gave you. Okay, yeah, I said factor that. So what you're going to do is you're going to graph that. Let's see. So I'm going to throw that into a Desmos or something like that. And you see, I see a third degree. You don't see that turning point up there, but what it does, it goes up. It's fifth degree equation. So I know the ending behavior is, so I go out to negative infinity, it should go down to negative infinity. And if I go out to positive infinity, it should go to positive infinity. So I know it's not going to turn back down there. I see 1, 2, 3, 4, 5 zeros. So I know there's 5 zeros, fifth degree equations to be 5, but you see there's only one or only 2 of them that are rational. The other 2 are these wonky rational ones. And if you were just to give me that those are the zeros and factor it, I would give you 0 points for it because you're supposed to be doing this without using tech. Okay, at least that part. So I see a rational root at -1. I see a rational root at 3. I also see the rational root at -1 is a multiplicity 2 because it bounced. Of course, we knew that. We knew that from before. So here, so what I'm going to do now is I'm going to come back over here since I've got a lot of white space on the screen. And I know at, what was it? It was at -3. Let's see, where's Desmos? -1. -1 has a multiplicity 2. So let's do some synthetic division with that. Notice I'm not using any of that bound stuff or anything. I mean, great math, but why? So I've got -1's a 0, and I'm going to do 1, 4, -21, -17, 40, and 33. So 1 times 1 is -1. You know how to do synthetic division, right? So 3, -3, -24, +24, 7, -7, which is 33, and 33 times -33, and I get 0. And I knew it was going to be remainder 0 because it would cross the x-axis. I also know this is multiplicity 2, so I'm just going to run that -1 through again. So -1, 2, -2, -26, +26, 26 plus 7 is 33, -33, and 0. And then that other 0 was what? Let's go take a look at the graph. See how I got rid of, I didn't do anything fancy. I just got rid of the, here's Desmos. I see the other real 0 is what? Not there, at 3. So x equals 3. So now let's run the +3 through this. So 1, so I get 3, which is 5, which is 15, which is -11, which is -33, which is 0. Now I hope you're seeing, I divided that fifth degree equation by a first power, by another first power, by another first power. So that tells me this 1 corresponds to 1x squared plus 5x minus 11. And of course, then I've got those other 2 factors, x minus 3 and x plus 1 squared. Okay, now if you look at that, you're going to go back up. I mean, you don't have access to that, though. You can use Symbol Lab, but or some other app. You see how that's what the original things that I had it expand. But the question is, factor it all to linear factors is usually what we have to do. So because this is, I can't factor x squared plus 5x minus 11. And I know I can't because those are awful, irrational values, right? So I know I've got to do something else. So what we like to do is use, quadratic formula at this point. Here, let me get Paint started up so we get a nice blank screen. Here it is. And then let me do a new file. So it's not white. Okay, so I'm going to run, now I'm going to do the quadratic formula with that quadratic part. So I know A equals 1, B equals 5, C equals negative 11. So negative B, X equals negative B, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So negative 5 plus or minus, then we go underneath the square root, do order of operations, 4 times 1 times 11 is 44, and it's positive. So I've got 25 plus 44 over 2. So negative 5 plus or minus the square root of, what is that? 69 over 2. And 69 is what? 13 times, no, it's 23 times 3. And neither one of those factors. So I'm going to write my factors negative 5 minus the square root of 69 over 2. And then I'm going to put an x plus that, right? Then times x plus negative 5 plus square root of 69 over 2. And then I got my other factors here. I've got my x plus 1 squared times x minus 2 or x minus 3. And that's the linear factors. So that I'm expecting you to be able to do. I want you to be able to, use the tech to find the rational roots, because why go through all that guessing and checking? A rational root theorem is great, but why use it when we don't have to? This part you need to use. Hopefully that makes sense and helps you get there. And this also works for if they're two complex roots. If I don't know if I'm gonna be able to make that graph, if I can change that graph so it's got complex roots off the top of my head. Let's see if I can change this. But if I change this to a plus, okay. Yeah, I see. Well, actually, there would be 4 complex roots. That's a much harder question. We won't go there. But you see what I mean? What happens is I probably won't be able to make this work. Well, that still has 4 complex roots. But what you'll see is the real number of roots, and then get rid of those using synthetic division, and then you'll end up with a parabola or quadratic equation. And you'll have to use a quadratic formula to solve that. Okay, hope that helps. Give me a yell if you need any help.